Hello everyone, welcome back to the computer network series. Today we are going to talk about three networking devices, hubs, bridges and switches, followed by the design principles of the internet. So the first question is, why do we need networking devices? Because in a network, many computers are interconnected. Hundreds, thousands or even millions. Data should reach only the intended machine or computer. Networking devices helps achieve this. There are three crucial devices which we are going to discuss today. Number one is hub, number two is bridge, and number three is switch. Moving on to the first device, the hub. The hub is a layer 1 device, or otherwise a physical layer device that will connect multiple computers and broadcast incoming data to all connected devices. So if there are 5 devices connected to the hub will broadcast the data. Broadcast means send to all. So broadcast data to all connected devices connected to the hub. A hub will never examine the address. So what is an address? It could be an IP address or it could be a MAC address. So IP address is not new to you. So this MAC address stands for Media Access Control Address. This address is a hardware address. Every device will have a MAC hardware address imprinted in the network interface card. So a hub will never examine the address. It simply repeats the incoming signal to every other port. Look at the picture. It shows 4 devices A, B, C and D connected via a hub. Suppose A wants to send data to D. A will send data to the hub first. The hub copies the data to B, C and D. All devices connected to the hub will receive the data, right? Only D processes the data. Fine. The remaining devices B and C will discard the data, right? That's a working principle of a hub. Listing the important characteristics of the hub operates at layer 1, physical layer. No MAC address table. It broadcasts data simply. It cannot filter the traffic. Very cheaper, low cost, low security, and could lead to many collisions. What are the advantages? It's very simple, damn cheap, and it's quite easy to install. What is the downside? The downside includes it wastes a lot of bandwidth because it completely broadcasts everything. It leads to more collisions, poor security, and slow performance. It is not scalable too. Right. Let us see the apartment mailbox analogy to understand the working principle of the hub better. The scenario is this. A mail carrier has a letter specifically addressed to the apartment 4A. So only the residents in 4A are the recipient. Instead of putting it in 4A's mailbox, they make copies of the letter and drop it into every single mailbox in the building. How to fix it? What actually is done? Residents in 1A, 2A, 3A, etc. will open their mailbox, will understand that it is not for them, and they will throw it back to the trash. Only the resident in 4A will keep it because it is intended to 4A. This is a very classic analogy that will illustrate the working principle of a hub. So because of this nature, we call hub to be an unintelligent device or a dumb device. Unlike modern switches or routers, these hubs will lack the intelligence to read the MAC address or the IP address of the incoming packet because they don't know who the data is actually for. They simply broadcast. Fine? Yes. Moving on, number 2 is the bridge. Let's assume a company, and the company has 2 departments, sales department and accounts department. Each department will have many computers. So if I'm using a hub, these many computers are there connected to the hub that's going to create a real heavy traffic. So what is the solution? I can use something called as a bridge. So what is the definition of a bridge? A bridge is a networking device that connects 2 LAN segments and forwards frames based on the MAC address. So there is a new term called frame here. At layer 2, imagine I call the data to be frame. So when we are talking about the ISO OSI layers, we'll talk about frames in detail. So bridge is simply a networking device that is going to connect two LAN segments and will forward frames based upon the MAC address. There was no MAC address in the hub. Now the bridge is going to forward your frame based upon the MAC address. Yes, so unlike a hub, bridge will learn which device belongs to which segment. There are two LANs, segment 1, segment 2, which device belongs to which segment is being understood by the bridge. Look into the picture. There are two LANs, LAN 1 and LAN 2. Fine. Device A and B is present in LAN 1. Device C and D is present in LAN 2. Suppose A sends data to B. The bridge checks the destination. B is in LAN 1. So the bridge does not forward the frame. The traffic stays inside the local LAN 1. Now, if A wants to send data to C, what happens? This bridge is quite intelligent when compared to hub. Bridge forwards a frame to LAN 2. That's the concept. Done? So bridge learns what address? Bridge learns the MAC address and builds a table like this, probably. So what are the advantages of a bridge? Lesser traffic, fewer collisions, better performance when compared to hub, and little bit improved security. What is the downside? It could connect only two LAN segments, slower than modern switches. Fine? Yes. So let us talk about an analogy to understand the working of a bridge better. So imagine two classrooms connected by a corridor. There is a messenger. This messenger checks whether the student is in the same classroom. If yes, no need to disturb the other classroom, right? If not, the messenger walks to the other classroom. Yes? So this is an analogy to understand the working of a bridge. Moving on, number 3 is the switch. The switch is the king. It's the most common LAN device today. A switch is a layer 2 device. Layer 2 is a data link layer that connects multiple devices and forwards a frame only to the destination port using the MAC address table. So a switch is quite intelligent when compared to the hub. Unlike the hub, the switch will not broadcast every frame, except for unknown destinations and certain broadcast frames. Fine? So that's about the definition of a switch. Look at the diagram. Devices A, B, C, D are connected to a switch. Suppose A wants to send data to D, switch will check the MAC table. It will forward only to D. B and C will never receive the frame. That's the working principle of a switch. Look at the MAC address table. A, port 1, B, port 2, C, port 3, D, port 4. Fine? So accordingly, it will be sent only to the recipient, not to everyone. Fine? Not to multiple recipients, if suppose it is intended only to the single recipient. Listing out the characteristics of this intelligent device called switch. It operates at layer 2. It uses the MAC address. It learns automatically. It is supporting full duplex communication, quite faster, secure, and collisions are minimal. Right? What are the advantages? High speed, efficient bandwidth utilization, quite secure, scalable, support virtual LANs too. Let us take one analogy for understanding this switch. The teacher privately hands the grade sheet to one student. Right? The teacher is handing over the grade sheet to one student so that no other student sees the mark. Fine. That's the working principle of a switch. To summarize the features of hub, switch, and bridge. The hub works at layer 1, whereas the bridge and switch works at layer 2. What is the address being used by the hub? Nothing. Whereas the bridge and switch uses MAC addresses. Hub is quite dumb, not intelligent, whereas bridges and switches are intelligent devices. Does the hub broadcast? Yes. Bridge? No. Filters between LAN segments. Switch also doesn't broadcast, except for few. For known unicast. Done. What about the collision domain? It's only one for the hub, one per segment for the bridge, one per port for the switch. What about the speed? Very low, hub, medium, bridge, high, switch. Security, very poor in hub, better in bridge, okay, best in switch. It uses a MAC table, hub, no, bridge, yes, and switch also uses a MAC table. Moving on to the design principles of the internet. Fine, to understand the ISO OSI protocol stack and the layering concept, we should know the design principles of the internet. The internet was designed to satisfy several fundamental principles. I appreciate and request you to see my first and the second videos for better understanding of this concept. Fine. So what are the design principles? Number one is scalability. The internet should support growth from few computers to billions, millions of devices without even redesigning the entire network, is it not? Scalability. Number two is reliability. Communication should continue even if some link fails or the router may fail. Okay, if one path is not available, the packet should take the other path. Reliability. Number three is interoperability. Different devices and operating systems should communicate using some set of common protocols. Fine. So for example, an Android phone should be able to communicate with a Windows laptop. That is interoperability. Number four is packet switching. Data is always divided into packets as we have discussed in the previous sessions, allowing multiple users to share the same communication links very efficiently. Yes? Okay. Number five is layered architecture. The networking functions are divided into layers. What are the benefits of dividing this into layers? Easier design, easier troubleshooting, independent protocol development. Yes? Done. Number six is best effort delivery. The internet does not guarantee delivery itself. It tries the best to deliver the packets with high layer protocols such as TCP, UDP, providing reliability when required. Done? That's best effort service or best effort delivery. Yes. Let's do a small activity. Scenario 1. A hub connects 10 computers. One computer sends data. How many computers receive the signal? Can you think? Can you answer this question? Yes, all 10 will receive the signal. Number 2. Why is a switch preferred over a hub? What could be expected answers? Higher speed, fewer collisions, better security, and efficient bandwidth usage. So these are the expected answers, right? So I appreciate you to read all these 5 questions and answer the 5 questions possible, post it in the comment section. We'll discuss the end of class questions again in another session. Number 1, why is a hub considered unintelligent? Number 2, at which layer does bridge operate? Number 3, how does a switch learn where devices are connected? Number 4, why are switches preferred over hubs? Number 5, explain any 4 design principles of the internet. Right? Any doubts? Post it in the comment section. I'll be happy to explain. Thank you. Happy learning.